Most of the time, we pay attention to clouds it's because of their effects on our local weather, or maybe it's because they make a sunset pretty. But what you might not know is that clouds affect us every day, even if you're staring at a clear blue sky. The clouds we see when we look out the window are an important component of the complex global weather system. They play a key role in Earth's water cycle, carrying huge amounts of fresh water and dropping it as a precipitation. And depending on their properties and where and when they form, clouds can have a dramatic effect on our climate, influencing the location and severity of floods and droughts, and even the temperature of our planet as a whole. All clouds share the same basic composition, but just by looking outside on 2 different days or even at different parts of the sky on the same day, you know that the atmosphere produces a huge variety of cloud shapes and size. Why do some clouds form entertaining shapes, while others look gloomy or even ominous? What's going on inside clouds that gives a distinct appearance? And could identify the different types of clouds help us predict the weather or even the course of climate change? We cannot really begin to analyze clouds without first categorizing their main variations. Most experts classify clouds into 10 or so separate types, according to 2 main characteristics: their height in the atmosphere and their shape. There are 3 height categories: low, middle, and height, and 4 shape categories. There is nimbus, means, rain cloud. There are low-hanging, flat gray clouds that can drop rain for many hours or more than a day if you are unlucky. Stratus means layer, which refer to their characteristic stacked appearance. Cumulus means heap or pile, but puffy might be a better way to remember than, and cirrus mean hair because it kind of looks like a fine wispy hair. Combination of 3 heights and shape characteristics can give cloud type its name. Also, they tell us about how they form and behave. The height at which a cloud forms has a huge influence on its composition. In general, the portion of the atmosphere where clouds form gets colder the higher you go. That means low clouds are almost always made of water vapor, while high clouds are made up of ice crystals, and middle clouds are often a mix of liquid and ice. These differences can often be seen in a cloud's overall appearance, with clouds made up mostly of water having a more clearly defined edges than ice clouds do. Cloud shapes can also tell us about winds in the atmosphere. For example, wispy cirrus clouds take in their characteristic shape because of strong winds high in the atmosphere, which pull at the cloud's flat edges. In some cases, clouds types in their characteristics can be used to forecast the weather. For example, cirrus clouds are often the first sign of the approaching warm front and can foretell long periods of steady rain or snow in the day to come. Middle-level clouds, called autocumulus, forming in a summer morning suggest that there is significant moisture and heat in the atmosphere, and that powerful afternoon thunderstorm might be in store. And if you see layered rain clouds called nimbus stratus outside the window, you might as well settle with a good book. It could be raining for a while. Scientists also study clouds for clues about their possible roles in climate change. For example, they discovered that certain types of clouds can cause the planet to warm, while others have a cooling effect. What we don't know yet, however, is which of these cloud types will become more or less common as a planet warms. Time will tell, and thus the researchers will be watching. You may well be familiar with fog, but have you ever wondered what it is and how it forms? Put simply, fog is a very low-lying cloud. Like a cloud, fog is made up of millions of tiny water droplets or ice crystals that form when air is cooled close to the Earth's surface and water vapor within condenses. Fogs are generally classified according to the physical process which produces saturation or near saturation of the air. The main types of fog are radiation fog. Radiation fog usually occurs in the winter, aided by clear skies and calm conditions. The cooling of land overnight by thermal radiation cools the air close to the surface. This reduces the ability of the air to hold moisture, allowing condensation and fog to occur. Radiation fogs usually dissipate soon after sunrise as the ground warms. An exception of this can be in the high elevation areas where the sun has little influence in heating the surface. Valley fog. Valley fog forms where cold, dense air settles in the lower parts of the valley, condensing and forming fog. It is often the result of temperature inversion with warm air passing above the valley. Valley fog is confined by local topography and can last for several days in calm conditions during the winter. Advection fog. Advection fog occurs when the moist air passes over a cool surface and is cooled. A common example of this is when a warm front passes over an area with snow cover. It's also common at sea when moist tropical air moves over cooler waters. If the wind blows in the right direction, the sea fog can become transported over coastal land areas. A very famous one is in San Francisco. Upslope fog. Upslope fog or hill fog forms when the wind blows air up a slope, called orographic uplift. The air cools as it rises, allowing moisture to condensate. Finally, you have evaporation fog. Evaporation fog is caused by cold air passing over warm water or moist land. It often causes freezing fog or sometimes frost. When some of the relatively warm water evaporates into low air layer, it warms up the air, causing it to rise and mix with the cooler air that has passed over the surface. The warm, moist air cools as it mixes with the cold air, allowing condensation and fog to occur. Evaporation fog can be one of the most localized forms of fog. It can happen when cold air moves overheated outdoor swimming pools or hot tubs, where steam fog easily forms, cold fronts or cool airs masses move over warm seas. This often occurs in autumn when the sea temperature are still relatively warm after the summer, but air is already starting to cool.